Finding the longest common substring. I believe that this problem is very important when it comes to dynamic programming. So, in this video, I not only want to focus on the implementation, but a little bit about the intuition behind that approach as well. So, let's see what we can do about it. Hello friends, welcome back to my channel. First, I will explain you the problem statement and we will look at some sample test cases. Going forward, we will see how we can start to approach this problem and then find an efficient solution using dynamic programming. After that, as usual, we will also do a dry run of the code so that you can understand and visualize how all of this is actually working in action. Without further ado, let's get started. First of all, let's try to make sure that we are understanding the problem statement correctly. In this problem, you are given two strings and you have to find out the length of the longest common substring between them. And obviously, if you want, you can find out what is that actual common substring also. So let us look at some test cases. In my first test case, I have these two strings. Now, these strings can have a lot of different common substrings. For example, I can find the string ZB in both of them, and I can also find the string BCD in both of them. Out of these two strings, BCD is larger, right? And that is in fact the longest common substring. So, for the first test case, 3 will be my answer, because the length of the string is 3, and my string is BCD. Similarly, if you look at your second test case, the first string is ZFBB and the second string is just a single character B. And what is the length of the maximum substring? It is just 1, right? You can find a B over here. If this was from any other character, let's say X, then the length of the common substring will be 0 because you cannot find a X anywhere over here. So for the second test case, 1 will be your answer. And B is your longest common substring, correct? Similarly, you have your third test case also. This test case is special because you have multiple common substrings. For example, you can find ABC over here and you can find ABC. Then you can find an XYZ, you can find an XYZ. And if you notice, you have XYZA and this is the longest common substring. So for the last test case, 4 is your answer. If you feel that you have understood the problem statement even better now, feel free to stop the video right over here and give it a shot once again. Otherwise, let us type into the solution. Let us suppose that you're given with these two strings. The most naive and the brute force approach to solve this problem is that you find out all the different possible substrings of the first string and then you find out all the different possible substrings of the second string. And then you are gonna compare each of the strings with one another and then find out, okay, this is the longest substring that I can find, correct? And then you can just return me its length. Or if you want to find out the string itself, then you can return, okay, this is the string, correct? Now, this is the most naive and the most time-taking way. You will have a lot of computation involved just to find it out. The method will work for smaller strings, but if you are having this problem in an interview or in a coding contest, then this method will absolutely fail. So we need to try and come up with a better approach. So what do you do about it? One approach that can come to your mind is that, okay, I will try to take up my first string and then try to slide over my second string over the first string. What will that do? So over here, I have my first string that is represented over here, correct? And what I'm going to do is I will take up my second string and then try to slide it all the way through the first string. The idea over here is that whatever will be the common substrings, they will overlap each other, right? Just look at it and then you will understand it better. So I start off with the first character. Right now, I do not have any character overlap, right? So now I will slide it one step ahead. What happens now? You see that, hey, I found one common substring, but this has a length of 1. So what I will do is, okay, I'm just gonna store the length 1 somewhere, right? And then I can update it later. For now, this is the maximum length I have found. What do you do next? Now you start to slide it even more. Do you find any common characters over here? No, right? So now go one step forward. Do you find any common characters? No. So keep moving ahead. Now do you find any common characters? You can say that, yeah, I found one more common string and this is it. Once again, its length is only 1. This is also equivalent to the previous length I had, so I will not update its value. Keep moving ahead now. And now what do you see? Now you see that, hey, three of my characters are overlapping each other. So this gives me a larger substring, right? And its length is 3. So what I will do is I will update my value, and now I can say that okay, 3 is my new value and BCD is the string. You need to keep moving ahead because there can be larger substrings ahead as well, correct? So now just slide one step ahead. You slide one more step, no common strings. Slide one more step, again no common string. Slide one more step, no common strings. Slide one more step, and once again you found common strings, right? You found that V and B are overlapping each other. So once again you found a common substring. But what if its length? Its length is once again 2. Right now you have a bigger common substring. So you do not need to update this value. Keep moving ahead now. It moves ahead, no other common substring, and then ultimately you are done, right? So you have traversed the entire string, and you were able to say that ultimately my maximum common substring was 3, right? This is basically one method of solving the problem. What are you doing over here? You're sliding everywhere, right? You start at this position, and then what you will do? You will find that okay, this is a common character, so you will try to go back and see, hey, what other characters do I have common? This is not common, so you stop. Once again, you will slide ahead, no common character. You slide ahead, no common character. You slide ahead, no common character. You slide ahead. And this time you see multiple common characters. If you will try to code it out, what will you do? You will say that, okay, D is common. So you will try to go back. You will say that, okay, C is also common. Then you will try to go back. You will say B is also common. Then you try to go back and say, hey, this time it is not common. So you stop. So this is the approach that you will be taking, right? For every character, you will try to go back and see that, hey, how many overlapping characters that I can get. And that is how you will determine your maximum length, correct? But if you notice, while you are sliding your string, you are doing repeated operations, correct? Because every time you slide, you are sliding at a new character and then looking at all the previous characters. Once again, you slide and then look back at all the previous characters. So this will end up taking a lot of time. But this tells you one thing. What if you can store the results somewhere? You will be able to look back in your stored results and then say that, hey, I know what is the answer in this case. And that way you can speed up your operations. What does this tell you? This tells you dynamic programming. So how can you apply dynamic programming to the same approach? Once again, I have these two same strings with me, right? And you have to find out what is the longest common substring. What I will do is, I will create this memoization matrix. And at the top, I have my first string, correct? And in the columns, I have my second string. What we will basically do is, we will try to start off with the first character, that is V. And then we will see what is the longest common substring when V is sliding over each of the string. Correct? Try to think about it. I take my first character V, right? I slide it at the first window. At this position, what is the longest common substring? That is V itself, right? Just one character. So I can say that at this position, the length of the longest common substring will be 1. Correct? Now what happens? This character slides on to the next character. These two are not same, right? So what is the length of the longest common substring over here? It will be 0, right? Because these two characters are not the same. So I write down a 0 over here. Similarly, this character now slides further. Are Z and B the same? No. So once again, I will write down a 0. Move ahead now. Z and C, they are also not the same. So write down a 0. Z and D are also not the same. So I write down a 0 over here. Now move ahead once again. Once again, you see the same character. So at this position, what is the length of the longest common substring? That is just 1, right? So I put down a 1 over here. And now I will slide my character one step ahead. Z and B are not the same. So once again, I will write down a 0. So now we are done with the first character, that is Z. Now let us move on to our second character. What we will now try to see is what will be the length of the common substring when my next character is B. So right now, compare these two characters, B and Z. They are not the same. So definitely, your longest common substring cannot be at this position. So what I will say is, I will write down a 0 over here. I know that there cannot be a longest common substring which ends at B and Z, correct? Now move ahead. Now I am considering this position, B and F. They are not the same. So once again, I will write down a 0 over here. Just give it a while and you will start understanding. Move ahead once again. What happens over here now? You see that both of these characters are matching. So it is definitely a possibility that your longest common substring is ending at this position. So your length will be at least 1, correct? And now, if you try to recollect, what were we doing in our previous approach? We had this string, right? And it was sliding all over the first string. This time, my string just reduces to ZB. And now we are sliding over this string. So just watch what happens with the character B. It does not match. It does not match. It matches. So what were you doing? You found that, okay, one character is common, and then you will try to go back and then compare, hey, is my previous character matching too? So F and Z are not matching. And in our memoization matrix as well, what can we see? We see this particular position, ZF and Z. The answer is 0 over here. So you are not finding any other substring that is ending over here. So you can confidently say that for this position, only 1 will be the length of the longest common substring. Now just keep moving ahead. You slide ahead and then you see the characters B and C. Once again, they do not match. So there cannot be a substring that ends at this particular position. So I will write down a 0 over here. Move ahead now. B and D again do not match. So I will write down a 0 over here. Move ahead. B and Z do not match. So write down a 0 over here. Move one step ahead now. What do you see over here? You see that B and B matches. So that means if your substring is ending over here, at least its length is 1, right? But also you have to start looking back. If you were doing the brute force approach, you would have to look back at each of the characters, right? You will start to go all the way back and see how many characters are matching. But this is where memoization will help you. You just look back. What is this? This is the entire string and this is the remaining character, right? And you know that at this position, you will find one more common substring. So ultimately, what I'm gonna do is, I will write down 2 over here. So what this matrix is telling me that if I have these 2 strings, then the length of the longest common substring I can find, that is 2, correct? Just keep moving ahead now and I promise it will be crystal clear. The next character that I take up is C, right? So I have my character and now it will slide all the way. So Z and C are not matching. So I write down a 0 over here. Move ahead. C and F do not match. So I write down a 0. Move ahead. B and C also do not match. So write down a 0 over here. Move ahead now. The character C now matches, right? So you can say that the length of the common substring will be at least 1. But at the same time, you also want to go back and check, hey, what is the longest length that I can find out? This matrix is once again helping you. If you look back, what is the string? That is ZFB. And if you look back, what is the string? That is ZB. And you have already calculated for this scenario. It is 1. So what will you do? You will do 1 plus 1 and that is a 2. So technically, what is this matrix telling me? Each element of the matrix is telling me the longest common substring ending at that particular position, right? Now keep moving ahead. C and D do not match, so I will write down a 0 over here. C and Z do not match and C and B will also not match. So at both of these positions, I will once again write a 0. We are now done with the character C. Move on to the next character now and that is D. So once again, I will apply the same process. D and Z do not match, so I will write down a 0 over here. As this starts to move ahead, D and F will not match, D and B do not match, D and C do not match. So all of these positions, they will be 0. What happens now when you move ahead? You see D and D. Both of these characters are matching. So once again, you know that the length will be at least 1. But you also have to go back to see how many other characters are matching. So my previous string is ZFPC and my previous string is ZBC. And you have already calculated the value. That is 2. So I will write down 1 plus 2 and that is 3. Now you see how this matrix is populating. Once again, move ahead. D and Z do not match and D and B will also not match. So at both of these positions, I will once again write down a 0. We are done with the character D. Let us now start with the last character F and complete our matrix. F and Z do not match. So I will write down a 0 over here. F and F, once again, they match, right? So the value will be at least 1. But if you look back, over here you just have one character, that is Z. And what is the previous character over here? That is D. You have already calculated for it and that is a 0. So this value will just remain a 1. Now keep moving ahead. F and B do not match. F and C do not match. F and D do not match. F and Z do not match. F and B do not match. So for all the remaining places, you will put down 0. So now look at this matrix. This matrix is telling you that if you have these two strings, then at each position, you can find out what will be the length of the longest common substring. And the maximum length you can find out, that is 3, right? So 3 is your answer. Now, if someone asks you, okay, what is the actual longest common substring? For that, you will start off with the largest element, that is 3, correct? And this will give you the character D. For the previous character, just go diagonally opposite. You get the value 2 and you get the character C. Once again, go diagonally opposite and you get the value 1 and you get the character B. And as you get a 1, just stop over there. So, if someone asks you what is the longest common substring, that will be BCD and that is how you derive it. So, if you try to think how will you implement this solution, it is very, very straightforward. Just keep on iterating through every element of the matrix. If both of these characters are different, just put down a 0 over here. If both of these characters are same, just add 1 to the previous element and then you will get your new value, that is 2. Once again, for example, if Z and D are different, just put a 0 over here. And if you can see two characters that are same, so just look at the value that is diagonally opposite and add a 1 to it. This way you will be able to populate your matrix, and then once you are done, just look for the largest value that you were able to find. That is the length of your longest common substring. Now, one thing that I would like to point out is this problem is very similar to longest common subsequence. If you notice, the longest common substring is BCD, right? But the longest common subsequence, that will include Z as well. Because in a subsequence, you can skip out characters. So longest common subsequence will be ZBCD. So when you encounter these problems, just make sure of it that what is the problem trying to ask you. Now let us quickly do a dry run of this code and see how it works in action. On the left side of your screen, you have the actual code to implement this solution. And on the right, I have these two strings that are passed in as an input parameter to the function longest common substring. First of all, we convert both of our strings to character arrays because that will help us to point at each of the characters individually, right? Now, once I have converted them, now I need a memoization matrix. So in the next step, I create a DP array which has rows and columns equivalent to the length of both of the strings, right? So my DP array will look something like this, correct? Next, I initialize a max variable. This is gonna store what is the length of the longest common substring. Currently, I just initialize it to 0. Now moving on with our for loops. And this is the main crux of the problem. What do we do over here? We just iterate over each of the elements of the matrix using these two for loops. And at every element, we check if the characters are equal. Then just copy the value from the diagonally opposite and add a 1 to it. So since A and Z are not same, you have initialized this matrix, right? So all of these elements will already be 0. So this is a 0. And then if you look at each of these different elements, none of them is Z, right? So all of these values will be once again 0. Similarly, when you start your next row as well, you will compare these two variables, right? B and A are not same, so you put a 0 over here. For the next value, B and B are same. If this is the case, just look at the diagonally opposite value and add a 1 to it. So 0 plus 1 will give me a 1. Moving ahead, C and B are not same, so put down a 0. D and B are not same, so this will be once again 0. This way, you will keep moving ahead through each of the rows of your matrix. And every time, you will try to update the max value with whatever value you are populating in your cells. At some time, this value is going to turn out to be 3 and then max will be 3. This is then returned as your answer, right? The time complexity of this solution is order of m cross n, where m and n are the length of your input strings. And the space complexity of this solution is also order of m cross n because you need that m cross n matrix for all your memoization. I hope I was able to simplify the problem and its solution for you. As per my final thoughts, I just want to say that I know that this problem feels very similar to the problem longest common subsequence. But the interpretation of the memoization matrix that you're creating, that is very, very different. So, have you seen any other such problems which follow the same pattern? Tell me all of it in the comment section below and it will become a nice collection for anyone else also who is watching the video. While going through this problem, did you face any problems? Let me know. I will be happy to discuss all of them with you. When it comes to dynamic programming, there is no technique that will fit all the problems. The best way to get better is you practice more and more problems and then you will be able to identify patterns. And then you will be able to say that, hey, this looks very similar. Instead of strings, this time it is just integers. So the approach will remain the same. So that is what you want to get better at. So as a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. Also, a huge shout out to all the members who support my channel. This really helps me. Keep letting me know what other problems do you want me to solve next. Until then, see ya.